Hey everyone, and welcome back to the channel. Today we're tackling a topic crucial for the UGC NET Library Science exam, probability sampling. Think of probability sampling like this. Imagine you need to bake a cake, but only have a tiny spoon to gather ingredients from a giant mixing bowl. You want your cake to represent all the flavors in the bowl, not just a clump of sugar or a pocket of flour. That's where probability sampling comes in. It helps us select a smaller, more manageable group, our sample, from a larger population in a way that ensures every element has an equal chance of being included. In this video, we'll break down the different types of probability sampling methods and explain each one in detail. By the end, you'll be well equipped to ace those UGC NET Library Science questions and apply this knowledge in real-world scenarios. So grab your notebooks, settle in, and let's dive right in. Let's kick things off with the most straightforward method. Simple random sampling. Imagine you have a giant bowl of M&Ms, each representing a member of your population. Simple random sampling is like closing your eyes, reaching into the bowl, and plucking out an M&M. Each candy, or in our case, each member, has an equal and independent chance of being chosen. Now, how do we ensure this randomness in practice? We can use tools like random number tables or generators. These tools spit out numbers within a given range, ensuring each number, and therefore each corresponding element in our population, has an equal shot at selection. Think of it like a lottery draw. Each ball has the same probability of being picked, making the selection process fair and unbiased. This inherent fairness is what makes simple random sampling a powerful tool for minimizing sampling bias and increasing the generalizability of our findings. However, there's a catch. While simple random sampling is fantastic for smaller populations, it can get tricky and impractical with larger ones. Imagine having to number each grain of sand on a beach. Not exactly feasible, right? Despite these limitations, simple random sampling remains a fundamental sampling method, laying the groundwork for understanding more complex techniques. Now that we've covered the basics of simple random sampling, let's move on to a slightly more structured approach: systematic random sampling. Imagine you're standing in line, but instead of picking people at random, you decide to pick every fifth person. That's the essence of systematic sampling. It starts with randomly selecting a starting point within our population list, like picking a random number between 1 and 10. This initial random selection is crucial. From there, we select every nth element after that. Where n is a predetermined interval, we calculate based on the size of our population and desired sample size. Let's say we have a list of 10,000 purchase orders and we want to examine a sample of 50. Using systematic sampling, we'd first randomly select a starting point between 1 and 200. If our random starting point is 57, we'd then select purchase orders 257, 457, 657, and so on. This method is particularly useful when dealing with large, ordered lists, like invoices or library card registrations. One of the advantages of systematic sampling is its simplicity and efficiency. However, it's crucial to ensure that the list we're working with doesn't have any hidden patterns or cyclical variations that might coincide with our sampling interval. Chapter 3. Let's say we're studying reading preferences among library patrons. We could divide our population into groups based on age: children, teens, adults, and seniors. Each of these groups becomes a stratum. Now, within each stratum, we'd use either simple random sampling or systematic sampling to select our sample. This ensures that our final sample includes a proportional representation from each age group. Stratified sampling comes in two main flavors: proportionate and disproportionate. Proportionate stratified sampling aims to mirror the population proportions in our sample. For example, if 20% of library patrons are teens, then our sample would also have 20% teens. Disproportionate stratified sampling allows us to intentionally oversample smaller subgroups to ensure we gather enough data to make meaningful comparisons. The beauty of stratified sampling lies in its ability to improve the precision of our estimates and ensure representation of key subgroups within our population. However, it's important to note that stratified sampling requires prior knowledge about the population to identify appropriate strata. Chapter 4. Imagine wanting to survey the reading habits of people across a vast region. Instead of randomly selecting individuals from the entire region, which could involve extensive travel, we can use cluster sampling. In cluster sampling, We divide our population into geographically clustered groups or clusters. These clusters could be cities, districts, or even neighborhoods. The process involves two main stages. First, we randomly select a number of clusters from our list of all clusters. Then, within each selected cluster, we randomly select our sample, either by including all members of the cluster or by randomly selecting a subset. Chapter 5. Let's say we're conducting a nationwide study on library usage patterns. Instead of trying to directly sample from the entire population, which would be incredibly daunting, we can use multistage sampling, a method that breaks down sampling into manageable stages. First, we might divide the country into regions and randomly select a few regions. Then, within each selected region, we might randomly select a few cities. Finally, within each selected city, we might randomly select libraries and then library patrons. This multi-stage approach allows us to narrow down our sample gradually, making data collection more practical and manageable. And there you have it, a crash course in probability sampling. We've journeyed through the world of random selection, exploring 5 key methods: simple random sampling, systematic random sampling, stratified random sampling, cluster sampling, and multi-stage sampling. We hope this video has clarified the different types of probability sampling methods for you. Remember, understanding these methods is crucial for acing the UGC NET Library Science exam and for conducting meaningful research in the field of library science. Don't forget to like, share, and subscribe for more educational content. Good luck with your UGC NET Library Science exam. We'll see you in the next video.